Okay, Mr. Gasser here. Here's 120. It's page 3. So what you should do right now is whoever's running this video should hit pause so you can copy this down. Do that now. Okay, let me explain some of this. This is a key page. Water is the main agent of weathering. What that means, the wetter the climate, the more weathering. Water is the main thing that causes most weathering, be it chemical weathering or physical weathering. Think frost action, abrasion, root action, all those require water. All those require water, as do a lot of the chemical weathering, acidic water with calcite, dolomite, and then water dissolving or reacting with the feldspars to produce clay. So, therefore, climate will affect how much weathering and what type of weathering occurs. In cold climates, your physical weathering is dominant, mainly because there's more frost action, okay? If it does not get cold, you're not going to have frost action. In warm climates, the heat will speed up chemical reactions, so chemical weathering is dominant. The hotter the temperatures, the faster chemical reactions occur. Chemical reactions occur slower when it's cold. So that is a key part. Make sure you know that. Surface area, we've talked a lot about surface area already. The more surface area, the faster the rate of weathering, be it chemical or physical, because there's more surface to be acted on by the water or more surface to be abraded. So, for example, loose sugar dissolves faster than sugar cubes. Here, you can see the surface area from here to here to here is increasing. I like to show this, that this block right here is 6 cubic centimeters is the volume. And when it's ground into a powder, it is now 60,000 cubic centimeters. So it's 10,000 times more volume, which is pretty crazy. I think I have some more. Yeah, this really shows surface area. So same total amount, same volume, same mass, but the more you cut it, the more surface area there is. So if you have abrasion, rock tumbling in a stream, the edges here really get abraded the most. More edges here, definitely more corners here. So there'll be much more weathering. Key to know that. What else do I have? I have this. This here, I made some changes to it, but basically it works like this. The more surface area, the more weathering. That'll be the graph. We're big on graphs in this. So more surface area causes more weathering. Mineral composition also really affects weathering. Actually, what you should do right now, pause this and copy this down. Okay, hopefully you unpaused it. Water is vital for most weathering. More water equals more weathering. Know that fact. Mineral composition. Certain minerals weather faster than others. Quartz will weather very slowly, but like physically, graphite will weather much faster because it is much softer. Is that better? Much softer mineral. A much lower hardness. Halite will dissolve in water. Garnet will really be difficult to dissolve in water. Rock types in general, sedimentary rocks are easier to weather because they're cemented together. The angular interlocking crystals of metamorphic igneous will be much more resistant. Okay, now this page here just refers to some diagrams, a bit of review. I know we saw this already. So pause it and copy it down. Okay, mechanical weathering is the roots getting in the cracks, breaking apart the bedrock. It's a type of mechanical weathering called root action. This, pause, copy this down. Okay, at this point again, the more surface area, the faster weathering will occur, the more in total, be it chemical and physical weathering. Pause it, copy this down. Okay, you may see this, recognize it from the first page. Frost wedging, frost action, a type of mechanical weathering, because water expands 9% when it goes from liquid to solid when it freezes. But this one, this is new. Copy this down, please. All right, the chemical weathering of feldspars. We know really plagioclase, potassium feldspar. Feldspar will react with water, and what you get, some of it will kind of be dissolved in the water, but there's a chemical reaction that you get to clay minerals, and you know clay from playing with a kid. Very different than the much harder feldspars. But that's where clay minerals come from, and that's the mud and muddy water. get carried down by a river, go into the ocean, form a sedimentary rock like like shale, sedimentary rock like shale, which may or may not become slate if it gets metamorphosed. So I'm going to stop this episode right there.